Hello everyone. This video will be the final video for Unit 4, quadratic functions, and it deals with the inverses of quadratic functions. What the inverse of a quadratic function is what's called a square root. So what we're going to do is graph square roots. First, notice the table here. If we had x is 3 and f of x is x squared, then that means f of 3 is 9, here f of 2 is 4, f of 1 is 1, f of 0 is 0, f of negative 1 is 1, f of negative 2 is 4, and f of negative 3 is 9. So now reversing x and y for f of x equals x squared. So if f of x equals 3, what was x? Well, x was the square root of 3. If f of x equals 2, then what was x? X was the square root of 2. So that when I plug in square root of 2 into this, I get 2. This would have been square root of 1, which is just 1. This is square root of 0, which is just 0. This, what number squared is negative 1? The negative values do not exist. There is no square root of a negative number. They do not exist. Solve f of x for f of x equals x squared for x. So what I'm going to do is let f equals x squared, then I'm going to solve for x. So I'm going to do this. That implies that x equals the square root of f, and then putting back in my function notation, x of f equals the square root of f. So the opposite of x squared is square root of f. Swap x's and y's since we are used to function in terms of x, so that implies that f of x equals the square root of x. And then the inverse notation is this negative 1 power. So if f of x is x squared, f inverse is the square root of x. So let's graph them. So our parabola, of course, looks like this, goes up this way. But basically what happens is we are going to invert this graph. We're going to flip it over this line. So when I flip it over that line, I get this type of thing. But this is not a function because it fails the vertical line test. So what we have to do is we have to kick off this bottom portion. And our graph of our square root function simply looks like this. All right? Is the inverse of f of x a function? Well, it is now. So what we have to do is we have to restrict the domain from when x is greater than or equal to 0. So let's graph both. So y equals f of x for x is greater than or equal to 0 looks like that. And the square root of x looks like that. This is root x and this is x squared. Notice they both should go through the point 1, 1. Because 1 squared is 1 and the square root of 1 is 1. Identify the domain and range. They're actually both the same. The domain and the range are from 0 to infinity. This is the definition of the domain. X must be greater than or equal to 0. So it gives us the domain right away. Now let's do it for this function. Solve y equals 9x squared for x. So that means y over 9 equals x squared, and then we square root both sides. So that implies that x equals the square root of y over 3, because the square root of 9 is 3. Then we swap x's and y's, we get y equals the square root of x over 3. Graph the inverse. So we still have when x is 0, y is 0. When x is 1, y is 1/3. When x is 4, y is 2/3. When x is 9, y is 1 or 3/3. So this graph grows very, 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 very small, very slowly. All right. Now let's look at an actual application. Following object form. The formula h of t equals negative 16 t squared plus h naught models the height in feet of a water balloon dropped from the initial height h naught. Let's consider we drop it from a rooftop that's 400 feet high. So here's our function. H of t equals negative 16 t squared. Maybe I don't know the time, but I know the height. So I'm going to solve this function for t. So doing this, first thing I do is subtract 400 from both sides. That implies that h minus 400 equals negative 16t squared. Then I have to divide both sides by negative 16. That implies that t squared equals, now I'm going to move this negative up, so make h negative and make 400 positive. So it's 400 minus h over 16, because it's bad etiquette to write a negative in the denominator. Then I'm going to square root both sides. This implies that t equals the square root of 400 minus h over 16. I could do this a couple different ways. I could do 400 divided by 16, that's a whole number, and then take the square root of that. But this way, leaving the function this way makes it easy to see where our domain values are. What does the inverse function represent in this application? Time in terms of height. Where the original function gives us height in terms of time. So now it says use the inverse function to determine the time at which the height is 100 feet. So I'm just going to plug in 100 for h and solve for t. So t of 100 equals the square root of 400 minus 100 over 16, which equals the square root of 300 over 16, which equals the square root of 300 over 4. Let's go 300 divided by 4 equals. So in 4.3 seconds, so it takes 4.3 seconds for this thing to only be 100 feet high. So it falls 300 feet in 4.3 seconds. Find an appropriate domain and range for h equals negative 16t squared plus 400. So for this function, my domain is going to go from time 0 to when it hits the ground. At what time does this hit the ground? Well, that's when this function is satisfied. So I would subtract 400, divide by negative 16, and then square root. So 400 divided by 16 equals, and then square root of 25 is 5. So it takes 5 seconds for this object to hit the ground. And the range goes from the lowest point of being 0 to the highest point of being 400. So the inverse is just these two flipped around. Now my domain goes from 0 to 400, which makes sense because if I plug in a number that's greater than 400 here, I'm going to get a negative in my radical, so I'm not going to get a real number for my t. I'm going to get a complex number. So that's why it's nice to leave it in this form, because it makes it easy to see our domain. And then our range is going to go from 0 to 5. So let's graph these two things next to each other. So if I graph it where this is t and this is h of t, then I'm going to graph it the other way around where this is h and this is t of h. So when time is 0, this graph is at 400. So let's make each line be 25 per 25 feet. So 50, 100, 150, 200, 250, 300, 350. Here's 400 right here. So there's one point on my graph. So now this point that's 0, 400 will also appear over here where h is 400. There's 100, 200, 300, 400 is right here. 0. So that point will now get reflected down to the x-axis and become this point. And then over here we said it falls at 5 seconds. So 1, 2, 3, 4, 5. Right here's where it hits the ground. This is 5 and that's 0. So our graph does this kind of thing. So now this point goes up here on the inverse. So now my t needs to be 5. 1, 2, 3, 4, 5. And my h is 0. And there's our graph. So all that happens is our axes get flipped. This was the t-axis, now it becomes the h-axis. This was the h-axis, now it becomes the t-axis. And notice our points just get flipped to the other side. What was the point 0, 400 now becomes the point 400, 0. And that's basically it. Now this next question I'm not going to do because this is one of your homework problems. Notice you'll have to restrict the domain on this one and cut this portion out. All right, so within your homework for this, your inverses homework, it's 3 questions, and 2 of them you need to graph in Excel, copy and paste into a Word document, and email it to me. So notice question 2 here talks about falling object. So this is just like the problem I just gave an example of, and the 3rd question has to do with the tunnel. So make sure you answer all these questions in my math lab, and then answer question E in your Word document, and then graph this for x greater than or equal to 0, and the inverse. All right, so later on today, what I'm going to do is I'm going to send you your final exam review, so we can start thinking about that. Notice your homework problems for Unit 4 are due 7/18, and your Unit 4 exam is due this Sunday at midnight. Next week is finals week. All right, so the 21st, 22nd, 23rd, 24th, and 25th is the finals week. So sometime during next week, you need to take your final either with your proctor or with me, depending on which form you signed at the beginning of the summer. There'll be some emails coming to you today to further explain that. If you have any questions, feel free to email me. Thank you, everyone, and have a wonderful day.